Hi everyone, welcome to the next video of Python tutorial series. In this video we will be discussing about machine learning and linear regression concepts, and today we are not going to do any kind of programming because I believe before getting into programming, understanding the concepts behind machine learning and linear regression will make you a good programmer, maybe a better programmer than someone who doesn't understand the concepts behind machine learning. So what is machine learning? Machine learning is an application of artificial intelligence, AI. So nowadays AI is a very fancy and everywhere it is being used. So it provides the systems the ability to automatically learn and improve from experience without being explicitly programmed. It doesn't really mean that we don't have to program a machine learning model. We have to program, but the thing is, once you program your model, it is done. You don't have to periodically improve your model by programming. The model itself will fine-tune based on the environment it is being exposed to. So that is the concept of machine learning. It is also a part of data science. There are three types of commonly used machine learning methods, which are supervised, unsupervised, and reinforcement learning. In supervised learning, we will be doing machine learning types such as regression and classification models. So in regression model, we will be predicting a continuous value in which the result will be in decimals. For example, we can predict the rainfall for tomorrow based on the previous historical data. In classification method, we can predict whether the email is a spam or not. So in unsupervised learning, the model is not exposed to any previous historical data. It is directly implemented, and in the real time it will do the predictions. So another thing is reinforcement learning. In reinforcement learning, the model will be given feedback at the real time based on its actions. If we tell the system that you are doing some mistake, don't do that, like negative feedback, it will take in that feedback and process it and adjust it accordingly. So continuous improvement will be there in reinforcement learning. So in this video we'll be discussing about regression model. So regression model is nothing but a part of supervised learning. So let's understand the dissection of supervised learning. Here we have a model. It will be exposed to a data, and the data will be split into training data and testing data. When the model is exposed to a training data, it learns from it and it becomes a trained model. And then when it is exposed to unknown data, which is test data, because we have only fed the model with the training data and the model is unaware of the test data. Using the test data, we can see how good the model is. We are going to use the test data for the evaluation purpose. So let's see what is linear regression is. So linear regression is a statistical approach for modeling relationship between a dependent variable with a given set of independent variables. So what is dependent variable? Dependent variable is nothing but result which we are going to predict. So here the dependent variable is commonly referred as target variable or label variables. Independent variables is nothing but the feature variables from which we are going to predict a result variable. There are two types of linear regression. One is simple linear regression and another is multiple linear regression. In simple linear regression, the independent variable, which is a feature variable, is only one, and in multiple linear regression, the feature variable will be more than one. We will see the simple linear regression concepts in this video. So let us say there are three scatter plots for plotted the x and y values. X is in horizontal axis and y is in vertical axis. If you see the first diagram, the relationship between x and y are linear. Whenever the x is increasing, y is also increasing. The relationship between x and y is non-linear, because here it is linear relationship because the relationship looks like a straight line. Here it is curved, so it is not a linear relationship. Same goes with the third image. It is negative curve, so it is also not a linear relationship. This is called non-linear relationship. First of all, when you are going to predict something using a historical data, you have to see what is the relationship between the feature and target variables. Relationship is linear, you can go for linear regression. If the relationship non-linear, there are other methods which we will see later, and there is something called correlation. So correlation is nothing but how a particular variable is changing with respect to another variable. So based on this correlation, our model can be determined whether it can be a successful one or not. Let us see one simple example. Here we have x and y. X is something you can imagine as input and y is output. So here x is our feature variable and y is our target variable. This is just for understanding purpose. In real time we will be getting more complicated data, and for each value of y, what is the value of x, we have plotted here. For our model we will be plotting a regression line, and this for any line the formula is y equal to bx plus a. Here b and a are called as regression coefficients, and b is slope and a is intercept. For predicting any new value of y, for the known value of x, if we substitute b and a from the formula given here, we can predict y. For the value of x, we are going to predict what will be the value of y. So here we will be drawing a straight line from x equal to 4, which meets here, and for the corresponding y value we are getting as 5.9. So this is how you predict a new unknown value for based on a known value of x. So here interestingly we have found that for the value of x, the y value is 8.4, but we already know that the true data is for x equal to 6, the true value of y is 8. So here there is a gap between the reality and our model. So this is called error. So the difference between the true data and our model prediction is called as error, and here in our case 8.4 minus 8 is 0.4. So the error is 0.4. There are three types of error validations which can be applied in our linear regression, which is mean absolute error. It represents the average error. The difference is calculated for all the data points of y, and it is summed up and calculated the average like this. Here n is number of data points and I for each y data points. So this is nothing but average error. There is a disadvantage in average error is the difference can be positive or negative based on the test data and the prediction data values. So there they have introduced mean squared error. So when you square the errors, it will always be positive. Only thing is we will be squaring the error values here, and then we will sum up, then we calculate the average of error. So it is called as mean squared error, and but this mean squared error will fall apart from the range of original data points values. So there they have introduced root mean squared error. This is nothing but after calculating the mean squared error, they will be performing square root. This will give you the result in range of the data points, so that is more interpretable. That's it guys for today, and hope you understand the concepts of machine learning, linear regression models in this video. So in the next video, we will be applying what we have learned in this video in Python. So until then, see you. Have a great day.